In this video, I will walk you through free response question number 6 from the 2008 B AP Calculus exam. This problem is primarily about horizontal and vertical tangent lines, but we will begin with some implicit differentiation. Consider the closed curve in the xy plane given by this equation. Part A. Show that dy dx is equal to negative quantity x plus 1 divided by 2 times the quantity y cubed plus 1. Let's differentiate both sides of this equation with respect to x. So be careful. When we get to the y terms, we will need to use the chain rule. So starting with x squared, the derivative is 2x. And then the second term, the derivative is 2. And now here comes the chain rule. The 4 comes to the front, and we have 4y to the third power. But because this is not an x, we have to multiply by the derivative of the inner function, which is just dy dx. And on the next term, the derivative of 4y is 4, and then just dy dx. The derivative of a constant is 0, so we have this. Let's get all of the terms involving dy dx on the left side of the equation and everything else on the right-hand side. So I need to subtract 2x and 2 from both sides. So these two terms will move over here. Now we have this. Our next move is to factor out the dy dx as a common factor in the front. So we will have dy dx out here in the front, and that leaves behind 4y to the third power plus 4 is equal to negative 2x minus 2. I think I will go ahead and factor out a negative 2 as I target what we are looking for. So I'm taking out the negative 2, and that will leave behind x plus 1. See how that gets us a little bit closer to what we are looking for. On my next step, I will divide both sides by 4y cubed plus 4. So this is going to end up down here. However, when I do it, I'm going to factor out the common factor of 4. So now I have this. If I reduce the 2 over 4, I will have the target. So that's it for part A. Part B. Write an equation for the line tangent to the curve at the point negative 2, 1. Whenever they ask us to write an equation for a tangent line, we always use point-slope form because it reminds us that all we need is a point and the slope. And they already gave us the point. It's the point of tangency. So the point is negative 2, 1. That means all we need now is the slope. We can find the slope of the curve at the point of tangency by evaluating dy dx at the point negative 2, 1. So we get negative 2 plus 1 over 2 times 1 to the third power plus 1. This expression simplifies to this, which equals positive 1/4. So that is the slope. The equation of the tangent line is y minus y, so y minus 1 is equal to the slope times x minus x. Well, x is negative 2, so this will become x plus 2. So that's the answer for part B. Part C. Find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. A vertical tangent line means dy dx is undefined. Dy dx will be undefined when the denominator is equal to 0. Dividing both sides by 2, we get y cubed plus 1 is equal to 0. Subtracting 1 from both sides, we have y cubed is equal to negative 1. And taking the cube root of both sides, we get y equals -1. So we have the y-coordinate. Now we need to find the x-coordinates. So let's substitute -1 in for y and solve for x. So now we have this, but then we have x squared plus 2x plus 1 minus 4 is equal to 5. So that's x squared plus 2x minus 3 is equal to 5. Subtracting 5 from both sides, we have x squared plus 2x minus 8 is equal to 0. Let's see if we can factor this. X squared factors as x times x. 8 factors as 2 times 4. To get a middle of positive 2, we need a positive 4 and a negative 2. This means that x is equal to positive 2 or x is equal to negative 4. Putting these x values together with this y value, there are vertical tangent lines at 2, -1 and -4, -1. Part D. Is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? Explain your reasoning. A horizontal tangent line implies that dy dx is equal to 0. But dy dx will only equal 0 when the numerator is equal to 0. But this means that x plus 1 is equal to 0, dividing both sides by -1, which means that x is equal to -1. If we are talking about points where the curve intersects the x-axis, we are talking about x-intercepts, which implies that y equals 0. But here is the original equation. If x has to equal -1 and y has to equal 0, let's plug those in and see if we get 5. When we let x equal -1 and y equal 0, the expression we get is equal to -1, which does not equal 5. So it is not possible to have a horizontal tangent at an x-intercept.